everyone, welcome to section 4.5. We are going to finally do quadratic equations. Now instead of just dealing with a quadratic, it's got to have an equal sign. This is going to be either f of x or y, and we are going to actually solve them. When we solve them, what we really are wanting to know is where does this quadratic equation cross the x-axis? And it crosses the x-axis at its zero values when y is 0. So the way we solve these is we make y equal to 0. Make y equal to 0, and then we can solve these equations. So let me walk you through a few and show you exactly what I mean. If you see this quadratic equation, x squared minus 5x plus 6 equals 0, and it asks what are the solutions to this equation, it's asking you what values of x would make this equal to 0. And you're not going to hunt and peck. I'm going to tell you what you're going to do, and it's pretty easy. What you're going to do is you're going to use all the factoring skills that we just reviewed and learned previously, and you're going to factor this. So first, make sure that your equation is set equal to 0. You don't need to move anything over, and this one is. And then factor this, because this is a 1. All you need to do is find two numbers that'll multiply to be 6 and add up to be negative 5. That would be negative 2 and negative 3. So that means this is going to be x minus 2 times x minus 3 equals 0. This is this factored. So this factored is x minus 2 times x minus 3. Negative 2 plus negative 3 is negative 5, and negative 2 times negative 3 is positive 6. Now, what values would make this equal to 0? Remember, anything multiplied by 0 is going to be 0. So what would make this binomial equal to 0? And what would make this one equal to 0? I'm going to show you how to do it mathematically, even though you can do it in your head, because some of these will get more confusing. If I have x minus 2, what would x need to be for this to equal 0? Well, x would be 2, because 2 minus 2 would be 0. So one of my solutions is 2. In this case, it's 3, because 3 minus 3 would be 0. So 2 and 3 are both solutions to this equation. If you graphed it, the quadratic would intersect the x-axis at 2 and 3, right next to each other. Those are your two solutions. Both of those values of x would make this equal to 0, and we have two solutions because this is x squared. In this next equation, the first step we need to do is move this negative 12 because it is not equal to 0. We need to put the quadratic on one side and 0 on the other. So first move the 12 over, x squared minus 7x, and it becomes positive 12. Now we can factor and solve it. So the two factors that multiply to be 12 and add up to be negative 7 would be negative 4 and negative 3. So this is x minus 4 times x minus 3. And so my solutions are 4 and 3, because that would make that one 0 and that would make that one 0. And there's your solutions, x equals 4 and x equals 3. Sometimes they'll even say, what are the zeros? It means the same thing. So you just do the same thing. The next few sections in your book spend a lot of time showing you how you can use your graphing calculator to do this. If you want to do that, knock yourself out, but I like doing things by hand, and so I'm going to show you how to do this by hand. In this case, you would do the same thing we did last time, set it equal to 0. Both of these terms need to be moved over. So this negative 2x needs to be added over here. So this will be 5x squared, and that'll become 32x. And I need to subtract 2, and now I have it equal to 0. I don't have a greatest common factor, so what I need to do is multiply, because this is bigger than 1, multiply 5 times 12, and that's 60. So now I need to find two numbers that multiply to be 60, add up to be 30 and 2. That one's easy, it's 30 and 2. So I'm going to rewrite this, splitting it between 30 and 2. So 5x squared plus 30x plus 2x plus 12 equals 0. This is the same thing we did last section, remember? I'm going to group these now. Greatest common factor, and factor that out, and factor out the 2. This is x plus 6. And so now my two factors are 5x plus 2 and x plus 6. Okay, those are my two factors. All right, now that I found my factors, now what are the solutions? So what do these need to be in order to make this equal to 0? This one's easy. This one's -6. So -6 is one solution. This one's a little trickier. If you need to write out the equation, 5x plus 2 equals 0, and then solve for x, you can. I know that this will be brought over and will become -2 and then divided by 5, so it ends up being -2/5, and those are your two solutions. And you didn't need to use a graphing calculator and put in all the numbers and then build a table and look all that kind of stuff up. But you can if you want. There you go. The next example in your book has you put this in your graphing calculator and look at your graph and see where it intersects the x-axis to find your answers. We're just going to go ahead and factor again because we can, and so we will. So we're going to set this equal to 0. 2x squared plus 7x minus 15 equals 0. I'm going to multiply these. I get -30. Factors of -30 that add up to be +7 would be 10 and -3. So this is 10 and -3. So 2x squared plus 10x minus 3x minus 15 equals 0. And I'm going to group that, factor out the 2x, x plus 5, factor out the -3, x plus 5. Oh, nice. So I have 2x minus 3 is one factor, and x plus 5 is the other factor. See how fast you're going to get once you get used to doing this? Those are my factors. What are my solutions or zeros? And this one is -5, so x equals -5. And this one, when I bring that over across the equal sign, it becomes positive. This one's 3/2, or 1.5, or whatever. And there are my solutions without having to graph. Nice. Here's your lesson check for today. It's already set equal to 0. There's no coefficient greater than 1 in front of the x squared. What are the solutions to this quadratic equation? Go ahead and just factor that and then give me the two zeros when you come in to show that you've watched this video. There's today's lesson check. The last section is the trickiest. What it does is it applies this to a word situation, and it asks you how far something went and how high. So that, because in real life, things that tend to go up come down, and we want to know how far did it go up and how far did it travel all the way across. The first example is a frog jump. When you visualize these things, you can visualize them at starting at 0, 0, going up and then landing here. And so my two solutions here give me the length of the jump, and my vertex gives me how high it went. So there's a complicated thing on how to use your graphing calculator. We don't need to do that. I'm going to show you how to do this by hand. And then if you want to figure out your graphing calculator, you are more than welcome to do that. But I'm going to show you how to do this without using that. Notice this is negative. All of these type of word problems, they're going to open downwards. So this should be negative. All right. So let me show you the steps to figure out how far this frog jumped and how high this frog jumped. My first step would be to find negative b over 2a. So negative b is negative 0.59 because that's my b. My a is 0.029, so double that, negative 0.029, double that for my 2a, and use my calculator to see what that would be. When I entered this into my calculator, I got about 10.17. Now remember that negative b over 2a is our axis of symmetry that goes right down the middle of our parabola, right? So think about that. When I drew this, that's the x of my vertex. So if I started at 0 and got to the vertex at 10.17, and I want to know how far the frog jumped over to the other side, all I have to do is double that number. Let me draw it for you so that it will make some sense. If this is the frog's jump and my axis right down the middle is at 10.17, then that means this point is also, this distance is also 10.17. So that means the frog jumped about 20.34, whatever the units were. And I don't know if they were inches or feet. Feet would be crazy, wouldn't it? But inches seem small. No, maybe not. Anyway, whatever. It's 20.34 would give you the whole length of the entire jump. It does not tell us how high the frog jumped. So in order to find that, we need to plug x into this equation and see what our y comes out. Our y is this height right here. When you do that, please remember order of operations. You have to take 10.17 and square it first. Then multiply that by negative 0.029. And then you can add to that 0.59 times 10.17 to get the height or the y of your vertex. In this case, it's about 3.0, about 3 feet, about 3.0. And yes, this is in feet. So the greatest jump, oh my goodness, was 3 feet high and over 20 feet. That's hard to imagine, a frog jumping that far. One other aspect to these word problems is you are going to be asked what's a reasonable domain and range that would represent a frog's jump. And you can use this equation to give you an idea. A reasonable domain and range would definitely, you wouldn't have a negative distance of a jump. This one was over 20 feet, so maybe a reasonable domain would be between 0 and 25. If you wanted 0 and 22, I don't know, maybe there's a super frog out there who can jump more than 20. But it's just figure that's kind of reasonable. And this jumped 3 feet high, maybe they could jump higher, so a range of 0 to 4 or something, you know, I don't know, would be reasonable. So a reasonable domain could be something like this. What does the book say? Yeah, the book even says 30. It gives lots of latitudes for a super frog, which makes sense. And for the range, the same idea, only they even give 5. So, but that would be reasonable. 100 feet would not be reasonable. Negative numbers would not be reasonable. You want to just use this as an example to give you a reasonable domain and range. Remember, domain is all the possible distances, and the range is the possible heights. All right, the last little practice for doing this is supposed to represent the flight of a kicked soccer ball in meters. The X represents the distance, the Y represents the height. So in this particular kick, how far did the ball travel? How high did it go? And what would be a reasonable domain and range for a kicked soccer ball, all in meters, I believe I said. So go through that same process, remembering that it starts at 0 and the X of your vertex, negative B over 2A, is the halfway mark. So do your negative B. And I'm not going to do this for you. You can do this on your own. Negative b over 2a gives you that axis of symmetry. So double that number to get the entire length, how far the ball was kicked, right? Because that's halfway there. And then take that negative b over 2a, whatever it is, plug that into here and here to find your height of your soccer kick. And then assuming that that's pretty average, add some to both to provide a reasonable domain and range. And if you have trouble with this, I'll help you in class, but that's basically what this section is. We are doing quadratic equations. Pretty cool. So have fun with those. I will see you guys next time. Bye for now.